Maybe we should wait 1 minute more to see if some people are joining.
So we have already 19 participants, Alexandra, which is super cool. If while we wait 1 minute for people to connect still, if you all want to tell us where you're coming from and your expectation on this webinar, that would be great. And we'll start in really a minute now. So yeah, I'll write a small message in the chat. So we have people from Sevilla.
Hello there.
So people are still arriving a bit, so we will still wait a small bit. Tenemos brasileiros? Tudo bem? Minnesota, okay, there's people that are freezing in the center, in the north of the United States. Hello. From Turkey as well. Yeah, I know I have a bit of echo and it's hard for me to change it. So Alexandra will make the presentation. Exactly. And we're going to start now. So Alexandra, the floor is yours.
Perfect. Well, welcome everyone. I'm very happy that you are here for our new webinar, digital phenotyping for crop protection. My name is Alexandra Bürgy. I'm imaging solution specialist at Hyphen, and I'm here today with the founder and CEO of Hyphen, Alexis Comar. Hello, Alexis. So yes, I don't know if you already know Hyphen a little bit, but Hyphen, and not only Hyphen for sure, worked during the last 10 years hard on digital phenotyping for everything that is agricultural testing on the field, but also inside in the lab and greenhouses to replace or at least add some digital measurements to everything that has been done or that is still ongoing on the field manually, which takes quite a lot of time. And with what can be quite subjective depending on the user who is doing the field measurements. And so with digital tools there are quite a lot of advantages. We can improve the traceability, the transparency as well, the precision, and for sure also the time that needs to be spent on the field or in the lab. And we are quite happy that finally the regulation finally is ushering into the digital era for, in that case, the product efficacy trials. So I'm speaking about EPPO. We will come back to that during that presentation. But now there are some guidelines out there, really a framework that tells us how to use really the digital phenotyping. So digital phenotyping is always about sensors and methods. I will also talk about that a little bit more in detail. And we are very happy that now we can use that kind of different solutions that are quite easy to use in the field or also inside on different trials, and to know how to adapt them to the product testing. So what you need to know is that when you would like to, let's say, replace manual standards, for example, the EPPO standards for product testing, we are talking about a trait. So a trait, that's a biophysical meaning, that's a characteristic. So for example, a disease quantification, but that could also be the height or something else of the plant that can be measured manually or visually directly in the field, or thanks to a sensor. So for example, an RGB camera, a multispectral or a thermal sensor, and a method. So a method I also will say something about that in a couple of minutes, because there can be several methods, and it also always depends what you would like to measure in the end, which sensor and which method to choose. So when we speak about sensors, well, they're not only sensors, but they're also the devices. So at Hyphen, we have different devices out there that are made to standardize quite complex traits in the field in that case. So for example, we have the literal system. You will see it a little bit more. That's only schematic. So you will see in another slide how it looks like in real life. But that's like a more or less handheld device that you put onto your body, and then you go still out to the field. But you take images of your different plots, you subsample your plot, and then, well, you go back to the office, send us the images, and we, in a very objective manner and quite rapidly, we can give you back different traits, so different measures. Here, for example, you can see diseases on wheat, for example, or on other crops. And for sure, there also exist other devices, for example, drones. I think that most of you should be quite familiar with that kind of device, or also phenomobiles. That's like a robot, a field robot, where we can also put different sensors on it. But well, when we talk about disease detection, for example, that can not only occur in the field, but for sure also inside in a lab or in your greenhouse. And also for that, we offer different solutions. So always combination of different sensors and different devices. For example, one device that is quite new and quite interesting for indoor use is the phenolite. So we also have a use case for that phenolite device later on. Here, for example, you can see that we can measure also different diseases on leaf discs. And if we need a little bit more throughput, maybe there exist bigger phenostations, bigger devices where we can do similar things. Then let's go back to the methods. As I said, a trait is always the combination between a sensor and a method. So let's take just 1 minute to talk about the different methods that exist, always for sure depending on the trait, on the characteristic that you would like to measure in the end of your plant. For sure, we are always talking about plants. So here we have, for example, well, everything that has to do with geometric interpretation of the plant. So here you can have a small schematic where you can see that with different sensors, that can be an RGB or different RGB sensors, or also a LiDAR, where we can have the vegetation in 3D. And thanks to that, well, we can have the plant height, or also the volume, the biovolume of the vegetation. Then we have different mechanistical models. So for example, that's quite scientific. We have the prospect prosale model to, for example, calculate the different chlorophyll indices, the leaf area index. So that is quite complicated. I don't want to go into detail here. It's just interesting that it exists. And last but not least, that's growing more and more is the machine learning sector. So everything that has to do with artificial intelligence, we have also different methods here: decision trees, deep learning, machine learning, and so on and so on. To detect different traits. For example, for diseases, that kind of method is quite interesting. But let's go back to the traits. And for sure, we could, in theory, replace all the different diseases, for example, following the EPPO guidelines that are explained in the different guidelines of EPPO. We could replace, for sure, all these traits with digital phenotyping. So with a specific sensor and a specific method. And it's really great that today, we know that it's not only possible, but there really exists now a new framework until the end of last year, also from EPPO, telling us how to validate the digital phenotyping, the sensor and the method, and to make sure that the results are validated and that you can use the digital measurements for your crop evaluations to have more precise, more objective, and also more rapid results at the end of the day. If you would like to know more about all these new EPPO standards, just write us in the chat because we are for sure quite interesting in everything that happens here today, and we are also here to really validate our methods that you in the end can use them for your official trials. And then a theory, well, no, that was more the theory, but how it then should work in practice, that's quite easy. Here's a schematic. Maybe it doesn't look easy, but in real life, it's quite easy. On your side, what you still need to do for sure is the experimental design. Maybe some of the image acquisition. If you have, for example, the literal system, a handheld system, you still go out to the field, you take some images, but it will take less time for sure that you will spend outside on the field, or maybe you will just fly a drone over your trial, or you will use a smartphone. It depends on what you would like to measure in the end. And then, yes, there's a role pipeline where you would upload the images to our platform that I will show you in a second. And then the image processing starts on our end with different validation steps. We would, for example, validate the image quality, but also the quality of the results to make sure that what we deliver you back is really of high quality and that can be used in the end in your dossier that can be submitted to EPPO, for example, or for you doing some analytics before. You will see that also in Cloverfield. So Cloverfield, that's the platform, the digital phenotyping platform that you will see in a minute, where you can already do some first analytics. So I would suggest to go directly to Cloverfield. For a live demo, I already prepared it here. So this is Cloverfield. Maybe some of you already know, Cloverfield, or maybe a similar platform. What I would like to show you here in the first view is, I think that most of you already saw that in the past. You have an image of your trial, and then you have different plots. So this here is a melon trial that has been flown by a drone. You can for sure see here on the left the different dates. So here, for example, we had different flight dates, and here we have all the different traits that have been analyzed for that trial. Green cover, for example, but also different chlorophyll simulations, vegetation indices, and so on. And what is now very great is that, if you click on one of the plots, let's choose a green one, you do not only have the color code, but you also have the real image behind. So you have the image of the plot, not only for sure, you also have the results, you can download them, you can play around with them, but on top of that, you have the plot image. The plot image of that specific date, but also the different images of all the flight dates. So you can see over time how the vegetation evolves. Here you can see it quite quickly until the senescence or maybe some diseases that occur over time. And this you can do it for all your plots. For example, the trial manager, if he wasn't on the field, he can just have a look after the flight on Cloverfield, or also after harvest, for example. You can still go back to Cloverfield and inspect your trial. But it's not all. We also added, you can already see here in the analytics tool, different views. Here I opened one because, we have quite a lot of data, so it takes quite some time to load. So I already did it here in advance. So here, that's still the melon trial. And what I show you here is a principal component analysis. So to see, differences, different behaviors of your plots. So I will just select, maybe not all of the dates, only the last ones, to just make it a little bit more visible. You can see that in real time the data is adjusted in the PCA. Well, let's take the green cover for all the dates, and then, well, you can see the PCA here, one part here, and then the different traits over there. And now, well, you can see if I click, for example, on that point, another one that is quite, on the other end, and maybe a third one over there. You can see that the different plots, were added here in that view. And you can see that they are quite different. So that's really what, that is about, is to see the differences in your plots quite quickly, quite easily. Not only for one date, but also over time, where you can see, well, the first one looks quite green in the beginning, but also until the end. Whereas, well, the second one, very quickly, the color changes a little bit. And for the last one here, you can see that very early in the season, there seems to be some disease, I would suggest. And the plant is dying quite fast. Maybe the last point to see here is that you can also color the PCA. For example, I think, yes, here we have different blocks. So just to see how the blocks behave in a general view in the trial. Let's go to another use case that I wanted to show you here. That is a strawberry use case that has been well acquired with a literal system. That is why here the plots look a little different, but you still have the images of, well, strawberry plants in the field. And what is interesting here is the ANOVA that we just added here. So where we can see, maybe let's go back here. You can see in that trial, so that's still the same. That's the strawberry trial with the literal system. Where we have here the modality profiler, where you can see we had different practices. Let's say that could be also different products with an untreated one, and you can see, depending on the trait, that there are already some differences. Now you maybe don't know if you have significant differences. So to know that, we added the ANOVA over here. So for example, if you would like to know if the green cover affects, in a significant matter, your modality, let's say, for example, your product or some treatment, you can compute the ANOVA here. That will take just some seconds. And well, in a second step, you make a post-hoc analysis, and you can compare really the different treatments, the different products, one to one, and see, for example, this one here is quite significant different. This one here, there's no difference. So there are already some tools on chlorophyll that can help you to understand your trial, and maybe also to help you doing your report. One last thing that I would like to mention before going back to the presentation and present you some more use cases is just the monitoring tool over there that has been included in Cloverfield mainly for a high number of trials. Imagine you have maybe 10, 50, 100 different trials in one country, or maybe also all over the world. Here you can keep track of, well, all the trials. You can see if the results have been delivered, or if there's something that you should know. Everything is here. We can write you a comment. We can also add different flags if something maybe during the flight wasn't as expected. And really the last thing before we go back to the presentation is the glossary. Just let us know if you would like to have access to Cloverfield. We have a demo account where you can just see different trials, play with it a little bit, and also have a view on the glossary, because here we have over 70 different traits that you can inspect, always with different with some explanations, with some images. Yes, so a lot of things to discover here. So plant height, well. Yes, well, let's go back to the presentation. What is missing about before we would like to switch to your questions would be some use cases first. So I would like to present you 3 different use cases. The first one would be one use case with the literal system. So finally, well, you can see what it really looks like. So the literal system, has here a sensor head. So you have 2 RGB cameras and a near-infrared camera to calculate, NDVI, for example, plant height, diseases. And on top of that, you have a 45-degree RGB camera to look a little bit, not only from the top to the vegetation, but also from the side. That is quite interesting as well for diseases that are, for example, on the leaves, where we really need to see from the side into the vegetation. Then that camera head here is on an adjustable stick that is then attached to your body, so your hands are free. You just need your hands to use the touch screen that is just in front of you, where you would select the different plots and then just acquire 1, 2, 3 different images per plot. It depends a little bit on the size of your plot. And what is really great with the literal tool is that we have quite good image resolution, as we are quite close to the vegetation. So that is why, especially for disease phenotyping, we have the resolution that we need to see and to evaluate the disease on it. But we can do even more. For example, that was the use case that I just showed you on Cloverfield. For strawberries, where we would like to know if my product had any effect on my strawberry plants or not. And so that's exactly what I just showed you. We have the modality profiler, where you can see in a box plot the differences of your different products. And then you have the ANOVA, where you can also see the product performance compared over the different products. The second use case that I would like to show you is based on drone images. So drone images, for sure, in that case, well, we are usually a little more far away from the vegetation compared to the literal system. And that's why very often, while the image quality is a little lower, for sure today we have quite good cameras that can be put on the drone. But with a standard drone, a DJI Mavic 3M, for example, or something else, the image quality for sure is less good than with a literal system. But the advantage here is that you can go quite fast over bigger trials, for example. So it always depends a little bit on the trial size, on the trait that you would like to evaluate at the end of the day. So all that will align the choice of the device that you should need for your trial. In that case, we used a drone to evaluate different nitrogen fertilizers to see, for example, which one would improve the nitrogen uptake in the plant. So what is quite interesting for the nitrogen uptake would be, for example, the leaf area index and the chlorophyll content. So both traits that can be analyzed with a multispectral sensor. For sure, there are quite more. And there can be also some more, for example, the NDVI to define the product performance. But what is quite interesting here is that, well, in the raw trial, it's quite hard to see any differences between the products. But with, well, digital phenotyping, with the digital methods, we can see still differences. Well, I see that they are not quite big, if you see the values over there, but still you can see differences. And that's really, the beauty of digital phenotyping is to see quite quickly if there are differences or if there are not. And depending on the results, you can not only inspect the different plots from your office, but also quite quickly decide if you would like to adjust your trial, for example, if you maybe also need to adjust the rates of your products, or maybe also the timing of application, and readjust the conditions during the trial. One last use case before we come to your questions is a little bit different. So this one is called Phenolite. That's like a small photo box that is quite flexible, and you can carry it from one place to another. So usually it would be for a greenhouse or a lab, or for some, for example, fruits, vegetables that are harvested or just sampled out of your trial. And then with a smartphone actually that is put over the photo box, you will acquire one or different images of, here for example, some vegetables, and then in just a few minutes you have a quality score. So today that can be the size, the color as well of the vegetables, of the fruits, or as well different diseases. So diseases, for example, exactly directly on different fruits, vegetables. That can be some diseases or some shelf life evaluation as well on strawberries, for example, or as you can see here on just leaves, where we can quantify quite easily with that device disease, phytotoxicity, or some other diseases on your plants, and have then the result not only directly on your smartphone but also online in a specific dashboard, where you can then generate scorecards to do your analysis. That is all from my side, and I suggest to go to the questions and answers.
Hello, yes, so there's a lot of questions. The first one, Alexandra, is could you go to the demo of Chlorophyll to show how you can import your own data with modalities, etc.? That's a question of Adrian Lund.
Sure.
So if you can make this demo, that would be cool.
So that's not the general upload, but once the upload has been done, or maybe I can just show both. Because in the beginning, for sure, after, for example, a drone flight or after some acquisitions with the littoral system, you need to go here to the upload tool and easily, you just select your campaign, your site, the acquisition date. And after that, you can just drag and drop all your images over there, you upload them, and depending on your internet connections, in some minutes, all the data will arrive on our site.
No, Alexandra, it's more the upload your own data with
the custom data. Okay.
Yes, so you can put modalities and stuff like that, and how it works.
Let's go back here. So here in that view, once all the results are already available, we will give you different traits, and then you can upload your custom data. So I think that is what you mean here. So there's just a template that you can download with different columns. So you need to indicate the plot name, and then the data that you would like to add. That could be a disease evaluation, yield data, or everything that you would like to add. Then you just drag and drop that file into here.
So, yeah,
and then it will appear here.
So what Adrian is asking is if he can demarcate a spray treatment area. The answer is yes, you can do it, but the logic of chlorophyll is to demarcate a spray treatment area by plots. So you need to have the names of the plots on which you're going to spray or on which you sprayed, and that's the information you're giving into chlorophyll. What we've noticed is most of the customers are struggling a lot with plot boundaries and making plot alignment and all that. The big companies and the small are all struggling. So we're often retaking that, and the easiest way to do it accurately is for you to have a logic of plots. So to tell us what modalities per plot, and then we delineate it for you, and you can do your analytics this way. There's Pavel that has another question on which is there a place for drones pilot in your workflow? So can you just quickly show the monitoring tool, Alexandra?
Well, I'll just go back to it. Yes, demo material. Yep. Sorry. Yes, here we go. Are you going
go ahead. So yeah, very quickly for Pavel, how do we help the drone pilots? In two ways. The first way is either we can, through APIs, upload all your images to the Cloverful platform with him just using his own tools, the tools of the company, when it's big companies. Either you can upload, as Alexandra showed it to you. Then we have a monitoring tool that shows you what has been uploaded, where we are in the processing. So our aim is to process everything in less than 5 days. That's highly achievable if all the data is good. So all the game is to be able to give a feedback as fast as possible that the data are not good, and that happens very often. So here is an example where you have flags. So we're able through all the process to give you flags. We're doing our best today to give you an ortho image in 2 days. Generally less. That's what we call the fast ortho function. And then we're doing all the processes where you're going to have flags that tells you, be careful, the dataset is incomplete, be careful, we're missing the plot file, be careful, we're having all that. So that's how it works to work with drone pilots, is really to help them manage their acquisition with the project manager of your contract. Then you're speaking about the 61 megapixel RGB camera with GSD as high as plus or minus 1 millimeters. Yes, we use that, especially for width head countings, and it works well. It's still relatively expensive, which means that a lot of customers are not buying it. The Sony ELX, I think, camera is the one of 61 megapixel on which we're really happy about. The gimbal is a GIMC, which we're not that happy about. And then you have a way better camera, which is the phase one. I can give you the link if you want. That is up to 120 million megapixel, but it's super expensive. So yes, we can have way more resolution, and yes, we can go below the millimetric centimeter precision. So that was for your answer, Pavel. I think all the answers previously have been answered by me, but we can go through anyway. So Stephanie was asking about if we're able to give the validation of our traits through EPPO guidelines. The answer is we're working at that very hardly. We're working on that very hardly with in two ways. First, with trying to have a public data set between our tools, so literal and drones, and validation measurements done by trialists that are accredited by EPPO. So this is the first thing that we're trying to do, is to collect this data set to then being able to validate our algorithm. And then it's about writing the dossier. So there we're starting to understand how it works. I think we will very soon have our first dossier that is, validation document that will be done. And then we can, if you have some specific traits, we can help you filling up this dossier between the ground truth measurements, which is EPPO measured following EPPO guidelines, which is not what we're going to do, but probably you, and the digital measurements, which we will do, and if the measurements are not precise enough, we can, through proof of concept, try to improve those algorithms to make sure that it matches and that it can be certified. So that's how we're going to work. So that was to answer to you, Stephanie. So yes, we are definitely going to help you to have a straight validation. And that's really where we're going to be extremely active in the coming months/years. So I gave again to Adrienne, Adam, the link of the EPPO guidelines. I hope you can all read it. It's super simple. You'll be a bit surprised on how simple it is. I think what is cool is it gives the guidelines. So at least there's something official that is out there that is proposing you a way to validate those data. Alexandra, if you want to go back into the slide that is describing them. It's not here. So the idea is to compare it with the analog results of EPPO guidelines. And it's they just want to have 60 data points out on at least 3 trials. So at least 3 data points on at least 3 trials. So it's not much. It's not really hard to do. I think it's easy to, I really feel that at the end, all of those things are based on good faith, on the fact that we're trying to be very honest and to sample the diversity well. I think there's lots of ways to go sideways, and the idea is to try to give some guidelines to show that we're careful about the traits we're doing, that we made the effort to show that we're careful about that. And then I think they will improve their guidelines as it goes and as they see that some things are not as satisfactory as they would like it to be. But me, what I find really enthusiastic, that is giving a lot of enthusiasm, is that finally someone is trying to take the problem. And even if it's super simple, even if there's ways to go around it, even if all that, we're having some first guidelines on which we can follow. And we can also give some recommendations to EPPO on how to improve those guidelines in the future. But this is really a way to try to push digital technologies in the crop protection world and probably in all what is trial efficacy. So I think breeders don't really care about that, but all the other trialists that are not doing breeding should care a lot about that, because I think it's the beginning of a revolution when regulation is starting to get interested into it. So that, I think, is what I wanted to say. Adrienne is saying standard setting for digital trait is very useful. Do you see any other official framework like this in the other geographies? The answer, Adrienne, is no. So I know that Phenom and Phasis, so the European plant phenotyping networks, is thinking of trying to do such guidelines. It will be very, very academical. And I'm a bit afraid it will take years before they agree, because once you want to be a bit more precise, it takes more time. Today, on all what is regulatory, unfortunately, US doesn't like that much, I feel. It's not a strong part of US. I haven't seen anything in Asia, but maybe I don't do my bibliography well. So it often comes from Europe, and that's a big thing in Europe. US innovate, Asia imitate, and Europe regulates. So it's unfortunately it's a bit how things works. Sumit is saying, can we integrate the environmental data with plant and soil traits to estimate genotype and environmental interactions? So the answer is we're doing that a lot. We're doing that a lot with all our customers. So to combine it, it's what we call agroclimatic traits. So we are working a lot on agroclimatic traits. It's definitely something that will enter into Cloverfield in the coming years. Today, what we realize is there's so many ways to incorporate environmental. Breeders are generally not that are keen to make mega environment on which we're going to make their analytics. Others are going to, modelers are going to use agroclimatic traits, etc. So there's so many ways to combine this free information, and of course we're working on all of them, but we're still writing a bit the specifications of what would be some generic tools and needs for everyone. But we're definitely integrating and that into Cloverfield. As a matter of fact, in Morocco, we work a lot in Morocco, where we are with ICARDA and UM6P, so two research institutes there that has lysimetric systems, and we help them interpret their phenotyping data and integrate it with environmental and soil data. So I hope I answered to this question. So I think I answered to all the other questions before. Let me check if there's maybe, yes, so Matt asked regarding the traits. So at Hyphen, we already have 70 traits, and I think it's already a lot. If you don't have a trait you want, either you can make some visual scoring on Cloverfield. So we can show you, Alexandra, if you want to show the visual scoring tool on Cloverfield right now, that would be super cool. And otherwise, we can do some proof of concept with you, or we can also integrate some algorithm if we validate them into the platform. So that's how we do. So here, go ahead, Alexandra.
Yes, so that's here. I just selected some of the plots, and then you can rate visually your different plots. So you can add a score, something else. It depends on what you would like to add here. You just give here, for example, score. It looks a little ill. 4 infested, and you go to the next plot. Here you can do the same, and like that. You go plot over plot. You rate your images.
So you can plot a subsample. There's a way to be able to show you how you can subsample the things you're going to rate, and then of course we can use AI, and this is phenomic predictions, which I presented 2 weeks ago in the previous webinar, how we can learn from all those visual scoring. So there's 3 ways. Either we already have a trait incorporated, and I think today we're one of the companies that has most traits available. Either you can do visual scoring and then we learn on that, or we can do proof of concept and we reintegrate regularly some new traits all the time. Disease is being the big one. So today we're able to do senescence information, we're able to do spot detections. But there's always some confounding factors. So disease is always a challenging one, but we're happy to discuss it with you, and we're happy to see how we can solve your problem. Generally, what I say is if Hyphen cannot solve your problem, probably no one can. Voilà, at least that's how we want to be. Emilio, I'm talking on the regulatory point of view. How can we be sure that a CRO is ready to perform this kind of digital assessments? So from a regulatory point of view, it's very simple, and this I think I understood it well. If a CRO has the right sensor, the right method, and a dossier that shows that with this sensor and with this method on 60 data points, he has matched 60 data points with ground truth validation, and that you're having a correlation, an R-square of 0.85, then it's validated. We know that R-square is clearly not the good metric. We know that there's a lot of things that can be improved once again, but from a regulatory standpoint, it's about having one sensor, one method. If your algorithm has been updated, so if you have a new version of your algorithm, you need to redo the work. But you're having one sensor at one version, one algorithm at one version, and then you're having 60 data points on free trolls that allows you to validate that your algorithm with your system is precise. I hope it answers your question, Emilio. That's so. Who's going to validate this? Well, yourself. The fact is that you need to say who recorded the data, so who used the sensors, who made the ground truth measurements. Our bet is to do that with research institutes or technical institutes, but I imagine that the big ones, like the big companies such as BASF, Syngenta, and all that, will probably do it by themselves. So they will validate it by themselves, and they will fill the dossier, and that's it. I think that's how it's going to work. So for CROs, I do believe that CROs will try to work with third parties because that's not their job, and that's where Hyphen comes in. We would like to do it with everyone, but I think that everyone can validate it by itself. They make a dossier, and if they lie, well, I guess that's the whole system that goes down, no? So I believe that today CROs, if they are inspected by local officials, they will say, "Hey, I bought a system from Hyphen. Hyphen said that this algorithm version 2.1 gives me this data. Me as a CRO or Hyphen said that they did 60 data points of validation with Arvalis or with IRTA or with any type of research institutes. They said that they are having this correlation curves between what they had between the ground truth measurement they did with technical institutes and their system and their algorithm, and we just used this one, and we can demonstrate you that we used Hyphen literal system with this algorithm. So yes, I definitely think that CROs are ready for that. Actually, we're discussing with all of them, and I think some of them are on this webinar listening to me, so I hope I'm not saying anything stupid. But yes, I do believe that today the responsibilities are very clear, and I think CROs are ready for that. I mean, I do believe that actually CROs realize that if they're not ready for that now, they will miss the digital transformation, and that might be dangerous for them. So I really think that it's a big shift, those EPPO's guidelines that arrived in 2024. I do believe it's going to take couples of years to shift, to have a lot of assessment made with digital tools. But I think that with those guidelines, the shift is going to take, and it's going to go in an exponentially fast way. At least that's my bet. And we're going to work hard to make sure that this is what happens. I hope I answer your question, Emilio. And don't hesitate to take also a meeting with us to discuss that further on. I mean, we're happy to discuss it further privately, to understand your concerns and to see if we can answer it. It's in the interest of everyone to go into the digital era. Is there some more questions? If there's not, it's almost, it's 50. So I guess already some people left, and we will call that our day. I would like to thank you all for having listened to Alexandra and to me on this webinar. We're really looking forward to work with you guys on digital phenotyping in the coming weeks, months, years. And we're super excited and going forward. So that's for more than 10 years we're in the business, and we really would like to be in the next 10 years with you in the business. Yes, so Emily says she's delighted to have a PCA for principal component analysis and the ANOVA for analysis of variance into Cloverfield. Yes, this is definitely something we did also a bit for you, Emily. So if you want, if you have copies of trials or you want to make trials and have those features, you can also reach out to Emily. That definitely can set up those trials for you, and we'll be happy to help. Thank you, Adrien. Have a great day. Thank you to all of them.
Yeah,
And
thank you.
and yes, and we will give regards to Lee, and don't hesitate to reach out to us, Emilio, again, to me, Lee, or Alexandra, if you want more information about those EPPO guidelines.
Yeah,
It's really the beginning of it, so we're really happy to listen also your thoughts and to see how we can move things forward. Bye-bye. Have a great day.
Goodbye.